for watching. So today I'm working more on my stock market model. I took some time off, but now I'm getting back to doing it every day. This is going to be a bit of a short stream because I'm trying to get back into the swing of things by getting the stream done. However, I only have about a little under 40 minutes before I have to go to work. So let me talk real quick over what I've done and where I'm going from here. Um, so the idea is I want to train a model on returns. I want it to be able to look at any stock and predict the returns. Um, and it should be, I'm looking for 53 or 54% accuracy, and then I'm going to use that to feed into a portfolio model, which will then make picks for the day. And my goal is to beat the S&P 500 by a significant margin. Consistently outperform the S&P 500. So the first iteration of the analysis I did, I got some data. I started out getting data from NASDAQ, but you need to download a CSV for each stock. And obviously, since we're updating every day, I want to make basically readjust my portfolio each day at the market open. And so since I'm making predictions for the end of the day, I'm going to need to get data on a daily basis. And I'm not going to go download hundreds or thousands of ticker data from NASDAQ websites. So I found this other data source, basically SQL databases that this guy updates every day. They're free. Oh, that's my other requirement, is all of this should be free so that anyone can use it, because I want to make something that works for myself, but I also want to make a generalized tool that anyone can use. So I found this guy puts this data up for free, and the link for that data is in the description. Also, the GitHub's in the description. If you go to the GitHub, there's instructions for getting this data onto your computer. And so once I had the data on my computer, I had to do some stuff to clean it up. The next step was to do a basic analysis, basically qualitative. Here I am looking at fundamentals. Let me move my screen. So you see bottom left here, fundamentals. Oops. Let me move my picture back. And then right here you can basically price data, see how it performs, see how each stock performs against the sector average. So this is healthcare stocks, pharmaceuticals. But this stuff is not really useful. You can't really automate anything with this. So the next step is to make a light gradient boosting method model, which works. This is a good model for stock data. It handles missing values well. It handles time series well. It's fast and efficient. And given that we have so much data, thousands of tickers over 10, 11 years, or actually like 15 years, we need something that's light and quick, because otherwise we'll get stuck in the weeds. And so I'm training the model on all stocks in a universe. I've defined a universe. Basically, you want to filter crap out of the universe. Anything that's random noise, penny stocks, stuff like that, you don't really want the model to learn on. You want it to learn on high quality stocks. And so I trained a model. The best I was able to get was about 51.5%. I did get some portfolio strategies which worked. The main thing I found that worked is that if I pick the lowest n number of volatility stocks, so get the, out of the top returns, let's pick the 500 lowest volatility and then allocate the portfolio accordingly to the predicted return for each. You can see that if I'm using 500 lowest volatility, I'm underperforming S&P slightly. 100, I'm basically matching S&P. 20, I'm outperforming S&P, and 1, I'm way outperforming the S&P. So then I looked at the Sharpe ratios. Basically, you need a Sharpe ratio above 1 for it to be usable. The only one that's above 1, Sharpe ratio takes into account the returns, and it also takes into account the volatility. And so you want high returns, but you don't want to trade off high volatility for high returns. Ideally, you would get low volatility with high returns. And so that's what this strategy is showing, but it's pretty fragile because only if I pick the lowest volatility stock it works. I then refined it by thresholding it, saying, don't just pick stocks that are, above 50% chance of going up. Pick stocks that are above, say, 51% chance, 52% chance. And neither of those was really better than just using straight up. But then you see if I increase the threshold to 53, the Sharpe ratio went up, way up. And if I increase the threshold to 54, it went way up again to 2.5. That's a huge Sharpe ratio. This seems like a good method, but again, it's fragile because I'm only picking one stock per day. And you see these are the lineouts for the three strategies here. And if I increase the threshold to 0.55, then it didn't make any picks. And so this is pretty fragile. I knew that I needed to go through and get a better version of the model. Get something that's getting 53 or 54%, like I said. Now, the problem with how the code base was structured is basically I had to make a new file every time I wanted to change the universe that I'm training on, every time I want to train the model differently, and every time I want to implement a different portfolio strategy. And so this quickly blew up to dozens of files. It wasn't going to be really usable by me long term. As I continue iterating, I need to rapidly iterate through different models. And then the other thing is this wouldn't be useful to anyone. So I organized the code base, I got some filters, I already had clean data, fed that into the stock universe, wrote a class for the stock universe, spent a long time implementing features and targets. This is all features and targets I've implemented. I tried to do everything I could possibly want to do for price data for now. Going forward, I'm going to incorporate fundamental data. And so now I'm working on, and I built a model class, and I'm working on this model. And so it's been about a week since I worked on this, so I have to refresh my memory of where I am. This is something I thought was a problem, turned out not to be. Oh yeah, so last time I basically improved the model by reading this paper. Let me increase the brightness of my screen and put some music on. I have just over a half hour, so let's... Oh, I thought my headphones linked up. Just a sec, let me hook up my headphones. I think my Bluetooth is off. Bluetooth, no, it's on. Okay, let's see. Okay, so where were we at? Let me find... There's so much stuff open, but let me see if I could find stock market tool. Here it is. Right. So now I remember I added these explorers, I call them. And I want to prototype different models and universes, but before I do that, I forget. So tests. Can we get much higher? And in data, did I add universes? Yes, I did. Okay, so Universe Explorer. So the first basic universe is just the default universe I've been using. Alright, so let's see if we could find out about how to use a universe for training LGBM on stock data. They say broken Spanish, me no hablo. LightGBM on stock data, large liquid universes, large and liquid. Performance attribution. Let's see, do they talk about universe here? Section 2, we define our data universe. We perform all our analysis on a proprietary universe, okay, of liquid stocks that we built with the data stream from 1990 to 2021 in 23 developed countries. The forecast horizon and data frequency is monthly. The starting universe had about 7,600 stocks. Kept only the largest stocks that sum to 80% of the market cap. Yeah, so that's about basically the same. So filter out penny stocks, get top 3,000 liquidity stocks, don't require uptrend, min history days. So probably we should have at least 30 days of data. And so devil in a Chrysler LeBaron. Volatility N. And we'll get back in Paris. Okay, so then we save data to universe one.feather. So I guess we should open can we get much higher? So let's make one and call this can we get much higher? Okay, so universe data. Universe 1 is top 3,000 by liquidity. Min price is $5. And I ain't got no kids yet, but I'm right here for practice. Advanced stats filter. Filters out stocks with over 50% crash in the last year. First, let's say this is going from one 2011 we got a main check to 2/1/2026. Filters out stocks with over 50% crash in the last year. Can't get enough. I need that. And in the town. Alright, so we have Universe Explorer. Model Explorer. Have you got a main chick, a mistress, and some hoes? Alright, so let's describe the models. So model 1, can't get enough, can't get enough, can't get enough, can't get enough. Test model 1 is true. Alright, so 1 should include what features? I heard you got a main chick. Let's just do every feature. Every feature that I can easily add. So one uses all features. I need that. Universe data. And then let's see. So code how ain't nothing to me. Model, yeah, so universe data equals pd.read feather model explorer. Oh, we need to import pandas. Read feather, so we're in model explorer, go up one directory, we're in explorers. Oh no, we're out of explorers, and then we could go to data. Dot data universes so here we have to get the universe, so let's do universe explorer, and we don't have universe, so we need to do, oh yeah, we have it. Okay, save. Let's get out of here. I don't give a damn what you think. Work, desktop. Oh yeah, I do want to go to work. CD stock market tool, CD explorers, Python 3. Oh, this isn't gonna work, is it? I don't think it's gonna work, but let's see. Oh, it is working. Okay, good. So I have to wait for this to run. So in the meantime, let's go back here. So universes slash universe dot feather, and then we could say model is equal to model universe data, and here we could say from clean analysis import everything. Click clack clow. Okay, so let's put all features we could want. So test features, and I just can't keep living this way. Test feature engine is where we want to start looking at it. So does this trend slope. Okay, so first okay, then we need from feature engine import everything. I gotta go to the bathroom real quick. We got on different shoes, live in the same building, but we got different views. Okay, so next 20-day slope on log price. Okay, so next, so let's just go through. I'm gonna write in here. Let's go my way, shy way, this way or the highway. 3/5/2026. Some interesting things to look at. And everybody else, thank you very little. Let's see, so I've almost doubled. Anyway. So some interesting things to look at. All features not ranked. All features ranked. And then from there we can all features ranked / not ranked with all different targets. Regression to log return target. Same thing here, regression to log return target. Okay, so only difference between you and me, you were gay. Oh, did he get his feelings hurt? No, he got titties under his shirt. Yes, I've lived a life that's full. I've traveled each and every highway. More, yeah, much more than this. I did it my way. How do I put that? Test features. So, is there a momentum test in here? I traveled each and every highway. I did it my way. But I'm hood rich. And everybody else, thank you very little. Unbeaten path. Them days. Oh no. Alright. Yes, I've lived a life that's full. I traveled each and every highway. But more, yes, much more than this. I did it my way. The shopper rumors. Okay, so let's just do so momentum feature request name is equal MOM for momentum. You and me, you were gay. Oh, did he get his feelings hurt? No. Yes, I've lived a life that's full. I've traveled each and every highway. Yes, much more than this. I did it my way. It go my way, shall way, this way or the highway. Alright, so shift -1. Yes, I've lived a life that's full. Momentum of log returns. Yes, much more than this. Input type. Feature request, input type defaults to log price. Slope of the log price. I don't think that's stationary. Okay, so input type, self.input type is input type, self.input type, self.input type. Yay. Okay, good. Input type is log return. Alright, so we've got slope, we've got momentum. Let's march through and get to other ones. So, did I give everything? Oh, alias. Alias is momentum. Okay, ROC, I forget what that stands for. ROC, return over something. Rate of change. So rate of change. So the rate of change, I don't know if that's going to be stationary, but rate of change. Let's see, what do I call it in here? Okay, so this is what I'm doing. This is what I'm gonna do on the next stream. I think I'm gonna probably do it tonight, but I might. There's a chance I might end up too tired. So I was just trying to get some momentum going, get a stream going, keep keep hammering on this project. So what I'm doing now is adding. We've got the universe, and so now I want to go through and say, if I add every single one of these features, how does the model do? That'll give us an idea of which features are important. And then also, if I add every one of these features in ranked version, how does it do? And then from that, that'll start to give me an idea of what features are important, and I'll be able to fine tune the model from there. But that's it for now. Thanks for watching. Have a good rest of your day. Subscribe if you thought this was interesting. Adios. Hammering on this project. So what I'm doing now is adding. We've got the universe, and so now I want to go through and say, if I add every single one of these features, how does the model do? That'll give us an idea of which features are important. And then also, if I add every one of these features in ranked version, how does it do? And then from that, that'll